Hello everyone. Good morning, dear authors and invited guests. I welcome you all to the technical session 7G. Hi, myself Siddesh Mogal and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025 Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December 2025 in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December 2025. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answer. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you to all the chair of this session, Dr. Krishnakant. Dr. Krishnakant is an assistant professor at Charator University of Science and Technology, India, with 16 years of academic experience. His research interests include image processing, deep learning applications. He is dedicated to advancing research and teaching in intelligent computing and visual data analysis. Welcome, sir. Do you have any opening remarks for the participants? Uh, Sir, your mic is mute.
Good morning, everyone. The participants, the presenters, and the authors, you are welcome here for the presentation. I hope you are going to share your work that you have done and your hard work in this particular presentation. Hope to see you in the presentation. Thank you, guys.
Thank you so much, sir. So let's move towards our first presentation. Our first presentation is presented by Elliot Kojo Atipo. He is presenting a comparative study of machine learning algorithms for predicting high school student performance. Sir, are you there, right?
Yeah, yes.
No, sir, the presenter.
Yes, I'm around.
Hi, sir. Good morning. You can start your presentation, sir.
All right. Good morning. My name is Elliot Kojo Atipo. I work at the University of Cape Coast in Ghana, West Africa. I am presenting a paper titled A Comparative Study of Machine Learning Algorithms for Predicting High School Student Performance. So in this study, we compare 7 machine learning classifiers on a Ghana high school dataset, then test generalization on an independent US cohort. So this is an outline for the presentation. We'll first talk about the motivation for the study, then look at the methodology, discuss the numbers that we got, and then talk about what it means for early warning signs. So the motivation for the study. Schools often have limited resources for support programs. So earlier identification of students at risk of poor final outcomes can help target tutoring, counseling, or remedial interventions. Many of the existing studies report strong reports on single data sets. Most of the existing studies use single data sets. Okay. Only few studies test generalization via external validation. But in deployment, we care about 2 basic things. Can we trust that the evaluation avoid a leakage? And also, would the model generalize to a different context? For instance, when extended to another school, can it generalize when it's extended to another region or even a different country? So the main operational preference is recall. So in this study, the thresholds are tuned to prioritize recall whilst maintaining acceptable precision. The whole idea is maximizing recall will mean minimizing false positives. Again, the data set used for this study is a mixed type, and then it's moderately imbalanced. So this study also reports on area under the precision recall curve, and also we do reports on the Brown score to see how well calibrated the predicted probabilities are. We do not just report on accuracy or precision. We look at how best the model discriminates. So that was a major motivation for this study. So looking at the development data sets, we pick a data set from Ghana, and it's made up of these features. We have predictors, which include demographics and context, something like the age, the region, the religion, the guidance. We also look at some study behavior, the hours the students use to study, and then we look at some prior achievements. There is what we call BEC results. That is the basic education certificate examination results. And then we also have a preparatory exam before they took the final exam. And the target variable is a general assessment, which is conducted for all senior high school students, which is known as the West African Senior School Certificate Examination Results. So that was a target variable. So we had, it was a categorical one. We had a good pass and a poor pass. This was a major target variable for the study. So this particular development data set was, the total data set was 2,705 students, and there's data made up of CCS record of one of the popular senior high schools in Ghana. And as usual, the predictors were some of these demographic, household context, the study hours, and the prior achievements. And then, like I said, the final outcome was the WASI results. So the data was moderately in balance. At least 60% of the target variable were passes and then 40% was failed. Again, looking at the external validation cohort was an independent United States data set with 2,392 high school students record. And the data set was harmonized. So that is the feature space limited to variables that were present in both data sets. Now to the methodology. The key methodological point is leakage control. So the pre-processing is fit straightly into the training fold. The training fold is made up of 70% and the testing fold was 30%. So the pre-processing is fit straightly inside this training folds where missing values were imputed, categorical values were encoded, and then scaling applied where necessary, especially the distance-based and margin-based, algorithms like the KNN, support vector machine, and logical regression. And because the data set was moderately imbalanced, we have to use smooth to ensure a fair balance target class. The model selection is done via a 5-fold cross validation. We do the 5-course model, and then we use randomized hyperparameter search to ensure we get the best parameters for the model selection. And then the held out data, the 30% tested, is then used to confirm the performance. Again, the decision threshold is tuned to emphasize recall whilst keeping precision acceptable. And this recall aligns with early warning use cases because maximizing this recall will ensure we reduce any false negative values and all of that. Then finally, the trained model are evaluated on this separated US cohort for external validation. The main agenda was to ensure transportability. So that was the methodology used for these studies. And in benchmarking, we had 7 main models, the logistic regression, the naive Bayes. The 7 main models were benchmarked. And then the results, we report on discrimination. We are interested in how best the models discriminated against the poor and the good passes, and focusing on area under the curve. We also look at the performance at chosen threshold. We also considered accuracy, precision, and then to check how best the model, we reported on the calibration, because we need to see how best the predicted probabilities were well calibrated. And then we generalize by ranking. The generalization was done by the ranking and the calibrations. We want to check whether it holds on external validation. So with the test set, we realized that the three ensembles led, especially random forests and then SGN boosts, the accuracy
Sorry
was
to
around.
interrupt you, sir, but your 9 minutes are over, so kindly wrap up.
All right. So the test sets we had the three ensemble method less the win. They had good Braille score. And again, looking at the external validation, we also realized that the same models, the ensemble, they perform extremely well. So what we realized was that the models trained in Ghana maintain high discrimination even after harmonizing. So calibration remained good. And then the key message is that the models trained on the Ghana data set maintain high discrimination, acceptable calibration when applied to different data set. So finally, we look at what drives the prediction. So we performed permutation importance and global sharp, and realized that the key drivers were proud attainment, steady effort, the mock exam, and then the steady hour. So this is just a brief overview of the study. Thank you.
Okay, I would like to ask you about your contribution. What is your contribution to this research work?
All right, thank you. So with the main contribution, we first use a clean tripod MO, which align evaluation with leakage-free pre-processing. And then we compare 7 main common algorithms used for this classification. And then we go beyond internal validation by externally validating the data on an independent data set. And then again, we add interpretability using permutation importance and then global shape to identify the key drivers for this study. Thank you.
Okay, next question is why you choose this random forest model? What was the reason behind it?
All right, so prior studies, we realized we studied a lot of works on predicting student performance. And I realized that the 7 main models were the ones that were commonly used. So that's why we decided to test it on our own data sets. So that was a major reason of picking those 7 main models. And at the end of the day, the random forest and then the support vector machine were the best performing models.
Okay, thank you. It was a nice presentation.
All right, thank you.
Next presenter.
Thank you, sir. Moving next. Next, we have Jennifer Chrysla T. She is presenting a time series machine learning framework for predictive analysis of geopolitical risk impacts on Indian equity indices. Ma'am, are you there?
Yes, sir.
Yeah, ma'am,
I'm
you can.
audible, sir.
Yeah, ma'am, you're audible. You can
Fine.
present your screen.
Yes, sir. So, good morning to one and all present here. My topic, I have chosen a time series of machine learning framework for geopolitical risk and Indian equity markets. So, why I chose this topic is because machine learning is a very developing tool which we need for our research. And it is the most advanced tool we must learn and we must inculcate in our research. And we'll see how it is helping in the volatility reducement in facing the risk and reducing the risk of stock market in Indian equity markets. So the motivation for my research is uh, how financial markets react sharply to the geopolitical events. So am I audible, sir? Because my speaker is a bit.
Yes,
Yeah,
you
yeah,
are
you are
audible.
audible.
Right. Go ahead.
Yes, sir. Thank you, sir. Thank you, sir. So geopolitical shocks such as wars and trade conflicts cause sudden volatility. Emerging markets like India are more sensitive. We are more sensitive and we only use traditional models like linear models or non-linear models. And we have to adopt a more forecasting model. That is what I'm going to tell about machine learning. So first is geopolitical risk. So geopolitical risk was widely accepted based on the news text. When Caldera and Ivo, when the authors introduced, it was based on mostly text global uncertainty measures, and it only concentrated on the threats and acts of the geopolitical risk. And it was widely used in financial risk analysis. Then, why study on Indian equity markets? Because Indian equity markets are deeply linked with global capital flows and oil prices. I have taken oil prices because it is very sensitive to it is very closely related to the Nifty 50 and Sensex as benchmarks. And it also limits the machine learning based geopolitical risk studies in India. So the research gap and objectives of my research is most existing study rely on linear econometric models. This study fills the gaps of by incorporating machine learning the already used models like ARIMA, XGBoost, and long short-term modules. So it also machine learning calculates how to improve the predictive accuracy present in the research. We can reduce the errors here and we can also be more accurate with the results. So the data I have used here is I have taken a period of 11 years. So, and the frequency is based on daily and monthly. Mainly I'm focusing on Nifty 50 and Sensex and we are mainly calculating here the global GPR index and the prudent crude oil prices. And we are mostly focusing on these both. So the framework which I have chosen is with the pre-processing of and stationary checks followed by the feature engineering model and the model training and performance evaluation. These are my methodological frameworks. The models used are ARIMA and XGBoost and LSCM. So ARIMA is based on linear benchmark model. XGBoost is non-linear N-assembly learning. And as I already told you, long short-term modules are mainly dealing with deep learning with the memory. So how far we can improve the accuracy by using the third module, that is long short-term modules. Sorry. So here we can understand how it is deeply dealt with the learning with the memory of the modules used. So to support this, we introduce the machine learning. So here I have evaluated my data like I have taken almost 9 years for training. The training period is 9 years. 2014 to 2022 data I have taken as training and I'm testing that data on from 2023 to 2025. I'm putting it to test And the evaluation matrix I am using here is RMSE, MAE, and R square. The key results are ARIMA, it underperforms during volatility, but XGBoost improves accuracy and LSTM achieves best performance. So as we can see, combining these models, we have got R square is equal to the error rate is 0.9. So it is less than 1 and it is obviously supported here. So with it, if we include machine learning, we can reduce the result furthermore. So the key findings are GPR significant. So geopolitical risk, it significantly affects the Indian market, and the effects on are non-linear, and it is not, it is and time lag, and it is also useful for the recent investors and policy makers. So I conclude by saying that machine learning improves forecasting, and long short-term modules is the most effective module. GPR here, it acts as a critical predictor. Frameworks is also applicable to the other markets, like not only stock market, but also other markets. Thank you.
Yes, madam. My question is that why you have choose LSTM model for developing your work?
Sir,
Yes, yes, please.
can't get you, sir.
Why you have used
Sir,
LSTM model? Are you able to hear me?
yes, sir. Yes, sir. LSTM model. Yes, sir.
Yeah. Behind it. What is the reason behind it?
Because it is more effective and it is more accurate, sir.
See,
Based
you
on
have
other
used
more,
you have used ARIMA, right? What was the problem behind in ARIMA?
it only focuses on linear processor and not non-linear progression. It doesn't focus on that, sir. ARIMA. It only
Okay,
focuses on linear benchmark model, and it doesn't focus on non-linear
okay,
and
fine. But
other.
according to your problem domain, why this ARIMA was not fitted? So I wanted the reason behind that, and then you have gone for LSTM. So that reason I am expecting from you.
Sir, I'm not sure of that. I'll look into the future for it, sir. Sorry.
Okay, okay. Thank you. It was a nice presentation, but we prepared with these all questions. If you are using those models, you should be very much clear that why you are choosing the model, what was the problem behind that previous one, according to your business or maybe your problem statement, whatever you have decided. All right.
Okay, sir. Yeah, sir.
Thank you.
Sure, sir.
Thank you. Thank you.
Thank you, sir.
Thank you, ma'am. Next, we have Sanjana S. Kaushik. She is presenting AI-powered 3D model generator.
Here to present our project titled AI-powered 3D model generator. This work focuses on converting hand-drawn sketches and prompts into realistic 2D image and corresponding 3D image. I will briefly cover the introduction, literature survey, system requirement specification and analysis, dataset, system design, implementation, testing, result discussion, conclusion. About introduction, an AI-powered 3D model generator uses artificial intelligence to convert sketches into realistic image and 3D model. Today, many creative fields such as design, gaming, and education requires 3D assets, but traditional modeling tools demand advanced technology skills. Our system specifies this process by allowing user to generate 3D model directly from sketches. When I come to objectives, main objectives of our project are to develop a multi-model input system, to implement deep learning model for 2D and 3D generation, to design an end-to-end AI pipeline. Our main problem statement is manual 3D modeling is time consuming and requires specified expertise. Most existing system supports only a single type of input, such as sketch or image. Hence, there is a need of an intelligent system that bridges 2D ideas and 3D realization. And it should be user friendly also. Main motive of our project is to make 3D model creation accessible to everyone, reduce the dependency on multiple tools, and empower students and creators to quickly visualize their ideas. Scope of our project is freehand sketch and prompt will be accepted as input, and output will be generated like sketch to AI generated 3D model, and that 2D image will be converted into 3D model with 360-degree view. We have used AI, ML, and deep learning. Platform we are using is web app with user-friendly interface. We can apply this in design, gaming, and education, and many other fields. Currently existing system technically provides either AI-based image enhancement or traditional CAD-based 3D modeling. These approaches requires technical expertise and lack seamless integration. So we are proposing this system to integrate AI-based image generation and 3D reconstruction into the pipeline. With one-click processing, user can generate both 2D and 3D models without prior knowledge of AI or 3D modeling. We have surveyed some literatures. Traditional 3D tools such as Blender and Maya are powerful but complex. Recent AI-based approach like Dream Fusion, Instant 3D, uses diffusion and NERF models to automate 3D generation. However, most of these systems focus on specific tasks and lack integration. These are the some papers we have surveyed. Some of will lack real time inventions, and some will lack the pipelining, like they won't provide all these in one model. One second. Comparison to like gaps in the current solution are they are single input. They will accept only single inputs. It is complex and it lacks seamless integration. So the uniqueness in our proposed system is it supports multiple inputs, generates both image and 3D model. It is very user-friendly architecture. In summary, our work combines recent AI advance into a unified interactive platform suitable for education, design, and creative application. Functional requirements are the system shall generate the 2D image from the sketch we are providing, and it should provide 3D model, and the output will be displayed to the user and 360 view will be given. It should allow the user to download or save the output. Non-functional requirements are the system should generate the results in few minutes. It should not take like a lot of time to generate the output. It should be compatible with Windows, and GPU will be used. Feasibility study of our project is the project is technically feasible using existing AI API, economically feasible due to open source tool, and operationally feasible for students. Sorry. These are the requirement traceability matrix of our project. The system architecture overview is this diagram shows the complete pipeline like sketch or prompt input and pre-processing layer. It will generate sketch to image using stable diffusion, image to 3D generator using Make It 3D or Dream Fusion API, and in output layer it will display the result. This is the use case diagram of our project. When if we come to our project's data set, we are using multiple data sets to generalize the project, generalize the output. We are using Sketchy Coco for pairing the realistic 2D images to help image and texture, color, and all. ShapeNet is used for 3D modeling, end-to-end learning. Berlin is used for cleaning the sketch, give more appropriate output. And we are pre-processing using these steps. We will remove the noise, normalize the image, scale the pixel values, line enhancement like sharp edges will be extracted, data augmentation, and tensor conversion. This is the way that one input sketch will be trained. It will check all the angles of the image while training. High level design represents the logical flow between the major system components, and
Ma'am,
low level.
sorry to interrupt, but your 10 minutes are over.
I
Kindly
would
wrap up.
like to conclude.
Just conclude in 1 minute, please.
Yeah. I would like to conclude and tell about future enhancement. In conclusion, the system establishes a strong foundation for AI-powered 3D generation. Future work includes textured 3D model, real-time preview, and advanced user control. Thank you.
Okay, I have one question.
Yeah.
What are the limitations of AI-powered 3D model generators? And how you have handled those problems or issues?
The one main limitation that we faced is the GPU. It requires a higher end of GPU version.
Okay.
Currently, we are buying the GPU computes for current scenario, but we are looking forward for the betterment of that one limitation.
And what were the ethical concerns related to your project or the work that you have done?
Sorry?
What were your ethical concerns related to your work that you have done? Because you are generating some images or 3D or 2D, right?
Yeah.
So there might having some chances of ethical concern of those images. So which technique you have applied and how you have resolved that?
This is a valid point, and we are planning to explore it in the future work. So,
Okay. For generating the images, which network you have used? Will you please let me know the network? Okay, no issues. Go ahead. Next presenter, please.
Yes, sir. Thank you, ma'am. Next, we have Naga Chandrika Google Mudi. She is presenting brain tumor segmentation and survival forecasting using Transformer. Ma'am, are you there?
On behalf of her, Ms. Suratia is presenting.
Okay.
Good morning, everyone. Today I'm presenting about our research, brain tumor segmentation and survival forecasting using Transformer. So coming to the abstract, nowadays in medical, we are using lots of machine learning models and advanced techniques for early diagnosis of the patients and taking care of them. So this project is based on the transformers, which help for the segmentation, semantic segmentation of the brain tumors in MRI images of the people. So as we are using transformers, which have the greater capturing long range dependencies in data, which is also known as self attention mechanism. So this model will aim to classify each pixel in the MRI images. So that's why this is called as semantic segmentation of the brain tumor. And coming to the problem statements, the brain cancer and brain cancer is the major causes for the deaths of the people. Recent stats say that from 1990 to 2020, there were around 6.6 in every 100,000 people who are suffering from the brain cancers. And also in the last year, alone in the United States, there were 25,000 deaths because of the brain cancer. So there is a very much need for predicting the brain tumor before it might cause some deaths or so. So it is very much required. And currently there are methods which are of the neural networks, deep learning and all, but they are having some problems with them. So the challenges which because of the for the traditional machine learning methods are like first SVM k-means and all. For these things, there are many features for classifying the brain tumor, they often fail to capture all the features. And also that because of the data set will be not that much high, so this machine learning models are sensitive and they might get into overfitting. And also they don't have generalization. They as when the data came from the non-trained data set, then they might get failed because of the generalization. And coming to CNN models, they only focus on the local features, like the features which are from the next pixel or so, but they will not focus on the entire global context of the image. So the performance drops on imbalanced data sets, for the tumors which are very rare, like 1 in 100,000 or so. So the and also for pre-processing, it requires a lot of dependencies and data augmentations for the CNN-based models. And the limitations for the transformer based models like UNITAR, transfuse, and transunitar, they require very much memory. And also, as the MRI scans are of 3D type, the computations will also be more, and the performance will be dependent on the CNN components which are present in these transformers. So this might increase the complexity of the transformers also. So our objectives are enhancing the brain tumor segmentation using a SWIN unitar, which is like a SWIN transformer along with a unitar decoder. And we need to improve the segmentation accuracy with the help of the self-attention mechanisms, which is present inside the transformer. And one more thing is integrating the MRI data with the survival information so that we can also predict the survival rate of the humans and overcome the data scarcity. Like with the minimal data, we need to get most of it. And we need to bridge the AI research for the real world clinical usage and also improve the diagnosis and treatment and for patient outcome. And this is the sample input. Like these are the 4 types of images which are drawn from the MRI. And the mask images will say that this is the region of the tumor which is present inside this brain. And the data sets which we have used are the BRATS 2021 data set. It contains 5 types of and 4 types of the input which we give. T1 weighted, you can see this one T1 image, T2 image, T1C, and flare image. and also the segmentation mask, which is called as output. And then the methodology which we used as the first thing is the dataset collection. We collected it from the Kaggle, the Bratch 2021 dataset, which contains the 1845 images of the training, which the training set contains 1845 MRI images of 370 patients, and the validation set contains 650 MRI images of 125 patients. And then we built the Swin unitar, which contains a Swin transformer as the encoder and unitar as a decoder inside it, uh, and then we extracted the features from the segmentation output of the Swin transformer. From this output, we extracted features like intensity, volume, shape, and also the spatial features of the tumor present inside it. And then the features which we have extracted have been merged with the original survival data set. Uh, and then we preprocess that entire data set through normalization, standardization, and also label binning. And then we use the principal component analysis to retain the most important features for the prediction of survival. Then we trained a random forest classifier on this data set for the survival for finding the survival rate of the patient. And then we integrated both the Swin unitar transformer and along with the random forest to predict the tumor along with the patient's survival expectancy. And you can see the model architecture here. Here, this is the input. At each layer, the image size will be half, and also the number of images will be doubled at each stage. And from there, the segmentation output will be present, and then we will be extracting features and merging with the survival data and building the random forest classifier. From there, we will get the life expectancy. For this sample image, the life expectancy is less than 6 months. As you see, the tumor is widely spread. And this is the art. Yeah, this is how in each stage the layers will be half. And these are some mathematical formulations in the Swin unitar. These are the formula for encoder. And then this is the formula for the attention. And this is the loss function. And then for feature extraction for each feature like tumor volume, mean intensity of the tumor, surface area estimation, tumor centroid. These are the features which we have extracted from the output of the transformer. And then the formula for random forest classifier, which is information gain. This will be found by this. And these are the results for this input of the brain. This is the output of which is predicted by our model. And these are our results, dice score and dice score for each of the brain tumor. Yeah, these are the average loss is 0.31, validation dice is 0.79, and for the each type of tumor, these are the dice scores. You can see, yeah, we have done the careful classification for the data set, and we have listed the average scores of each thing. And while comparing with other models, you can see ours is more better performing than the other models which have been previously there. And coming to the conclusion, this transformer architecture enhances the brain tumor segmentation in MRI images by integrating both survival prediction along with this tumor segmentation. So by leveraging this advanced self-attention mechanism of the transformer and also the cross-model features which we have integrated the Swin unitar transformer along with the random forest classifier, this will be easy for predicting the patient survivor. And also this reduces the manual intervention of doctors and all, and also improves the diagnosis efficiency and consistency of the model. Thank you.
Thank you. It was a nice presentation. My question is, why are transformers preferred over CNN for brain tumor segmentation?
Yeah. Because CNNs don't have the concept of generalization. Like they, once you have, if you are giving a data set of some 100 patients image, when you are giving the 101th data image, it doesn't try to get all the features. Like it will just be trained on the present features. Like if you are, it might get overfitted. Like it don't have long range dependencies and all neural networks.
Okay, and you talked about self-attention mechanism, right?
Yes,
So
yes.
how does it help in tumor segmentation?
Yeah. Like, self-attention mechanism itself states that there are, as we are giving images, right? So the images are classified into pixels. In self-attention mechanism, if there is a pixel number x, it will contain the data of the pixel number x plus one, x plus two, and all the images. But if because of it, we can it is easy to predict, like, if the pixel x is tumor infected, there is a high chance of getting the previous pixel or the above pixel, below pixel to get infected by the tumor. So this lags in the CNN neural networks and machine learning models. That's the reason transformers are highly preferred for tumor classification.
Okay, thank you. It was a nice presentation.
Thank you.
Thank you, sir. Next, we have Manisha Sangvi. She is presenting extending expectation confirmation theory to explore investors' reuse intention of robo advisory platforms. Ma'am, are you there?
Yes, I'm there. Am I audible?
Yeah, ma'am, you're audible.
All right. All right. Can I start?
Yeah, you can share your screen first.
I
Yeah,
have
yeah,
shared.
I can see. Sorry, you can start.
All right. Very good morning to one and all present over here. So my topic for this particular presentation is extending expectation confirmation theory to explore investors' reuse intention of robo advisory platform. So I'm Dr. Manisha Sangvi. I'm going to present this particular paper in front of you. So this is going to be the flow of my presentation. So first I'll speak about the context of this theory, why this topic and why it is important to do some research on this particular topic. Literature review, I'll give you a little glance about it. What is the objective and the gap? How did we find? And what the research methodology we find, data analysis findings, and the conclusions. So the main context of this particular, one sec. So, in the context of this particular presentation is I want to understand the objective and what are the factors which are influencing the reuse intention of the robo advisory services. So when we mean to say the robo advisory services, we mean to understand the investment using the AI tool. So there are few investors who are using these days the AI tool who are providing the investment decisions, and are they keen to again reuse those particular tool. So this particular present study, we have taken the behavioral biases, trust and expectation confirmation theory is what we have used for this. So here we are going to analyze the confirmation biases, trust, satisfaction, which influence the reuse intention of robo advisory. Now, why this particular study is important? The study is important because, of course, the AI is something which is a next boom, and when we talk about this service increment, there is a huge AUM which has been increased under the robo advisory services, and which is expected to increase a lot by the year 2028, as it is as per the Statista 2025 statistics. And in India also, it is expected to increase to 22.5 billion. In 2025 by the end of this year. So this is going to be the AUM, and it's a huge growth which we see often. So basically, advisory investors are important because human advisor, they are a little high with the charges. They're not 24/7 which are available, and it has been already been cited by many studies for these particular thing. There are many studies which has been done on this particular area, where expectation confirmation theory, it talks about the widely use of the consumer adoption of various financial product. But for the robot advisory services, this particular theory has not been implemented, and that is what we are bringing as a gap here. On the reintention use, Kumar et al. 2024, he has defined that reuse intention as a user's behavior inclination to continue using the fintech services after the primary experience. The confirmation biases that we have taken, that speaks about, that refers to the people's propensity to look for the evidence to confirm their preconceived opinion. And it has already been cited by many of the authors. The third construct that we have spoken about here is a trust. That is a trust toward the robo advisory. So trust forms the biases for investors' decision to use and reuse the robo advisory services. It has not been dependent on the services, but also on the dependability on the reliability of this particular whole system. Nayan and Rajan in 2024, they have reported that the investor not only do not trust the technology, but also exhibit faith in the robo-advisory services. So trust impacts investor reuse intention of robo-advisory, and it also serves as a safeguard mechanism. The next construct that we have worked on it is satisfaction, which talks about it's a very important determinant because it measures the overall experience about the investors with this particular service. There are many who have cited that satisfaction usually leads to the reuse intention, and however, the impact would vary based on the situational factor. These are the five theories which we have formed hypothetically. There is a positive relation between the confirmation bias and trust in the robot advisory services. There's a positive relationship between the trust, satisfaction, and robot advisory. So these are the mediation hypothesis we have created. And then we have spoken about the direct relation of the satisfaction and the reuse, the trust mediation of the confirmation bias satisfaction, and the satisfaction mediation between the trust and the reuse intention. So to understand this whole hypothetical method, we have used the research methodology. We have taken a purposive sampling. The reason being choosing this particular method is there are not in India so many users of robo advisory. So purposely we have to pick up the one who are already using it so that we can measure the reuse intention. Respondents, as I said, they are the investors who are using the services. The data we have collected between the March to September 25, and the total sample size we have used is 205. And these are the measurement scales which we have taken from these particular authors' seminal papers. And a 7-point Likert scale we have used it. We have used the EFA, that is exploratory factor analysis, and the SEM PLS. The softwares we have used here is the SPSS to check the EFA, and Smart PLS we have checked to check the reliability and the validity and the multicollinearity issue with the model. Descriptive statistics where we have seen that the most investors that we have are with the age between the 25 to 35 and 35 to 45 is the major respondents that we have it. Major respondent, again, the investors are male over here and 42% with the female. And the investors who were having the most number of experience were having the less than 2 years or 5 to. So majorly what we had is the investors who had up to 10 years were the major respondent for our survey. Now, these were the data that we got through the output of the PLS, where we can see that all the constructs where we can see the factor loading is more than the 0.75, which shows a good loading against each particular factor. The Cronbach alpha for each particular construct, which should be more than 0.70, and it is as per the here et al, and it is more than 0.70. Even the composite reliability. So Cronbach alpha and the composite reliability, we have checked for the reliability of each construct. And AV, which is the average variance extract, that should be more than 0.50, which is above much particular threshold. And VIF, which basically talks about the multicollinearity. So VIF stands for the variance inflation factor. It checks the multicollinearity among the predictor construct, and it should be less than 0.30, and in most of them it should less than 3.3, and it should not exceed 5. So for the RU, none of them have exceeded more than 5. The right side of the data, it shows the HDMT. And HDMT is basically, it shows the discriminant validity of the construct. So it shows whether the constructs are distinct from each other or it is overlapping. So anything with the value less than 0.85 is a good construct. So all the values are less than 0.85, and it shows that the constructs are not overlapping. Now, this is the results of the PLS, where we found that all the particular hypotheses have been supported, and they all have the positive correlation with the construct. So you can see that the CB is impacting the trust. It is also significant, whereas the trust is also impacting the significant level of the satisfaction and the reuse intention. So to precisely, if we summarize my findings of all the statistical what we have analyzed, it speaks that investor reuse intention towards robo advisory services is strongly driven by the confirmation biases, trust, and the satisfaction. Whereas I've already shown that the confirmation biases to the trust has a positive significant, trust to satisfaction it shows a reliability, transparency, and accessibility significant enhance the investor satisfaction, and the satisfaction impacts the reuse intention. So the theoretical contribution, we have extended this particular ECT theory to fintech by integrating the behavioral biases. The median analysis we have done is, which has provided a deeper understanding, and the mediation analysis as an indirect effect we have mentioned over here, that the confirmation biases, trust and the satisfaction. So yes, there is a trust is mediating factor, and it is a significant relationship. Trust, satisfaction, and the reuse intention. So satisfaction acting as a mediation, which is again a significant mediator between the trust and the reuse intention. So we have done a sequential dual mediation analysis where we have seen that the CB has influences the reuse intention indirectly to the trust and the satisfaction. The R square value, anything which is more than the 0.20 for the social science studies, of course, that shows a good analysis. And the trust has shown an R square is 0.265, which mentions that 26.5% of the variance of the trust has been analyzed. Satisfaction is showing 42%, and the reuse intention is showing the 37%. So overall inside of this particular thing, all the constructs are driving the adoption of the reuse intention of the robot advisory. So implication of this particular study is, the major and very important thing is, if we want to continue these particular investors to be using these particular services, we need to prioritize this transparency, performance, and the communication. And the design should be the user friendly design, so that it allows them to use this particular application, implement proactive trust building measures, and enhance the investor satisfaction to encourage the future adoption of the robot advisory services. All the hypotheses which I have already mentioned, as a statistically they have been supported, and indirectly confirmation biases also affect the satisfaction via the trust. And so both the mediation also have been trust. So limitation on this particular study is the number of the data that we have collected at 205. So and the purposive sampling, the reason I have already denoted why we have used the purposive sampling, and uh, this particular study has these number of respondent. The data is collected only from the Indian investors, so that is again a limitation for the study. The focus study, the future scope which we can be done is, of course, the sample size can be increased, and more in different cities, this particular model can be checked. And more constructs, maybe the perceived risk and the usefulness can also be added to this model to understand how it is impacting the reuse intention. The moderating effect can be also be checked in this particular analysis. This can be done in the future. These are the references which have been used. And thank you so much. I'm open for the questions.
Thank you. It was a wonderful presentation. The topic was very much interesting.
Thank you, sir.
My question is that how you have measured your hypothesis that is related to truth and satisfaction.
How I've used the
How you have justified your work with respect to the truth and satisfaction. One of your hypotheses you have mentioned in the
right
presentation.
trust and right. Right. So this is we have taken from the literature through the previous work. So trust impacts the satisfaction is what we have analyzed with that
Okay.
studies previous, and we have used that.
But how you have used in your work, I'm asking.
Because these are the main constructs which are something for any particular services.
Mm-hmm. Is there any problem that you faced while implementing those hypotheses?
To use these particular construct for that. But yes, we have added the CB using the ECT theory, which is something which is a huge gap over here.
Okay. Thank you. Wonderful presentation. Thank you.
Thank you so much, sir.
Thank you, ma'am. Thank you, sir. Next, we have Nandan Kumar VR. He's presenting gas line leakage detection using AI and IoT.
Sir, I am audible, sir.
Yes, sir, you're audible.
Yeah. Good morning, sir. I am Nandan Kumar Veer, and I am presenting our paper titled as Gas Line Leakage Detection Using Artificial Intelligence and IoT. This work carried out under the guidance of Dr. Chetan HK, sir, Professor of Department of Computer Science and Engineering at MIT Tandavpura. And next come to the team members, and this project is a team effort by the Bhavya N, Divyashree BM, and Megan NS. Next, 1 second, sir. Next, come to the introduction. Gas line leakage is a critical safety issues, especially in urban areas where multiple homes are connected to a centralized gas pipeline. As developing cities are implemented the underground gas pipeline under the one in the small
Not audible properly, huh? You're not audible properly.
project focus on developing a smart automate. Yes, sir.
Uh, Mr. Nandar Kumar, you are not audible properly. Your voice is breaking.
Hello, excuse me, sir. I'm audible.
Yes,
Yes,
sir,
yes.
you're
Now,
audible.
okay.
In the introduction, gas leakage is a critical safety issues, especially in urban areas where multiple homes are connected to a centralized gas supply. And developing cities like Bengaluru and some of the city Hyderabad, these cities are implementing the underground gas pipeline. Even a small leakage can lead to several accidents such as fire and explosions. This also affects the humans and the society. To overcome this problem, the project is focused to develop a smart automated leakage detection system using artificial intelligence and IoT. Next, come to the literature survey, which studied the several existing systems based on Arduino Uno, Node MCU, and IoT platforms. Most existing system solutions focus on detection and alerting, but they have limitations such as delayed responses and lack of automations and or limited monitoring. Our work to improve upon these systems by integrating real-time monitoring, sir, using intelligence detections and automatic gas set off using the solenoid valve. These are the papers. Um, these are some of the papers that we have referred, sir. Next, come to the proposed system, the gas pipeline leakage detection, which is based on artificial intelligence and IoT. And our proposed systems continuously monitors the gas flow and pressure using the sensors. Um, and any abnormal variations indicates possible leakages. Once detected, the systems immediately trigger and an alert is and set off the gas the supply the automatically using solenoid valve. And now come to the what are the sensor we are used. Flow sensor. This flow sensor is to measure the rate of the gas flow in the pipelines. And next, come to the pressure sensor. Monitor the pressures variations inside the gas pipeline. Next, come to the relay module. Relay module is automatically cut off the gas supply during the leakages, sir. A buzzer. This provides the immediate audible alert. Next, come to the solenoid valve. This automatically shut off when gas is leak when gas leak is detected. And next, come to the ESP12E. This is the microcontroller. Act as a main control and enables Wi-Fi communications and ThinkSpeak. ThinkSpeak is used to real-time cloud monitoring and data visualization, sir. Next, come to the project output and screenshots. The figure on gas leakage detection model, what we have developed. Figure on shows the working gas flow detection and these things, and the figure 2 shows the ThinkSpeak dashboard. Where real-time sensors can visualize it. This allows both local and remote monitoring. Next, come to the system architecture. These are the system architecture gas pipeline, and uh, the diagram shows the overall system architecture. The sensors collected the real-time data and send it to the ESP12E, what is the microcontroller. This controller process this data and triggers the alerts if leakage is detection, and uploads the data to the ThinkSpeak cloud for remote monitoring. Next, come to uh, what are the experiments results of the test cases. Next, we has tested the system under the multiple conditions such as normal gas flow and sudden pressure drops and abnormal sensors. We test In all the cases, the system successfully detected abnormal behaviors, responded appropriately by activating the alerts, set off the gas supply. Next, come to the performance analysis. High detection. Our system shows the strong performance in several aspects. This high detection accuracy, reducing the false alarms and fast response times. This time is if detects the gas leak and set off the gas supply within 1 to 2 seconds, and stable performance during the long-term operations. Effective cloud monitoring. This is a real-time data is uploaded to ThinkSpeak, and using the ThinkSpeak for real-time and historical analysis. Next, come to the future enhancement. Mobile application can develop in future. We plan to enhance the system by developing a mobile application instant alerts, adding battery backup for uninterrupted operation, introducing self-health monitoring to detect the sensor for any failures. These are the reference we are referred to the while designing the and implementing our system. That's also. Thank you.
Okay. Now you have to, your work is good, but I wanted to know that how this IoT, this AIoT that you applied in the architecture is best fitted for gas leakage monitoring.
Sir, one second, sir. Can you repeat again?
I'm just asking you. I'm audible properly to you?
Yes, sir.
What IoT architecture is most suitable for your gas leakage monitoring system that you applied in your research work?
Sir, through the sensors and
which gas sensors is going to provide you the optimal accuracy?
optimal flow sensor, sir. Pressure sensor. The pressure sensor is monitoring in the monitoring to the ESP12 controller, and the flow sensor is continuously monitoring if one point to another point. If you take 100 points, if one flow is used 10 points, and remaining 90 points are supplied to the next sensor. If any leakage is detected using this transferring pipe, if any next flow to sensor, if is less than 90 or 85, it will detect this in this pipeline is gas is detected.
Okay,
Leakage
good.
detected.
Okay, good. Next presenter, please.
Thank you, sir.
Thank you, sir. Next, we have Shamala P. She is presenting monitoring coral reef with YOLO's V5, a survey on real-time approach using machine learning. Ma'am, are you there? Shamala, ma'am? I take this as no. Moving forward. Next, we have Vijayashree M. She is presenting multimodal Parkinson disease detection using deep learning.
Yes,
Hello.
Audible, sir?
Yeah, ma'am, you're audible.
Audible. Go ahead, please.
Good morning, everyone. Our project name, Parkinson's disease prediction using audio and video through the expressions using the deep learning. For this project, why we use the deep learning? Because it's a type of ML based on the artificial neural network, which multiple layers of processing are used to extract progressive high-level features from the data. So we're using the deep learning method for this. And we are using deep learning methods because it can automatically analyze the complex images and speech to detect early and suitable for high accuracy, which predict the high accuracy for the project. Yeah, going to the introduction, it's a PD, it is a mainly a brain disorder that mainly affects on the movement, speech, and the facial expressions. And mainly correct diagnosis methods depends on the doctor vision observations, which can also be objective to and manage to detect the disease earlier. So because of this, there is a need for more accurate and early detection methods. We are using the this is a neurological generative disorder which affects the motor functions and including speech or face expressions. Here there is in the traditional diagnostic methods we have lack of detection, early detection. So we came up this project to detect early the disease. So here we can see some face expressions about normal people. We can see difference between the normal persons and the PD patients in the face expressions, as it is anger, fear, happiness, or sadness. So when going through the problem statement, this project proposes about the deep learning based on the multimodal. Multimodal means we are combining the both the voice and the facial expression analysis in this prediction. So it is used to enhance the prediction accuracy more. So this system aims to provide an automated, invasive, and early stage diagnostic tool which improves the clinical decision making through deep learning, and which make the doctors to predict easy the disease in the earlier stage. And we can see here the graph as years are going, and this disease is also increasing and we can predict early. So when it comes to the proposed system, the proposed system uses deep learning to analyze both the video, means facial and the movements patterns, and the speech signals to help the detect of PD. So it works on the two ways. One is the image or video recognition to observe both, for image and video recognition, to observe both the facial expressions and movement changes in the faces, and the speech. When we come to speech recognition, it identify the voice related symptoms like shivering. When we are speaking we can see the changes in the voice like shivering and everything. So, and these methods are trained on large data sets, so they can recognize early signals to the disease. And by combining both video and the speech, the system provide more accuracy and reliable results, which helps to helping early diagnosis and continuous monitoring on the Parkinson's disease. And here's some literature survey we did on this project and the paper. As we are taken the papers published here from the 2024, and as we can see in the literature survey, there are only few.
Dear madam, kindly skip this literature survey and talk on the gap that you've identified.
Sir,
Okay,
pardon?
please skip this literature survey. Just get me know the gap that you have identified and go ahead with that.
Okay, sir. Uh, After this literature survey, we go through the functional requirements at the data sets we are taken. So this functional requirements means as we go through the audio, we take the extensions and image and the video. So as we are going through data sets, for audio features we use the librosa and parrot with parcel mode, which uses the random forest, XGBoost, SVM for the audio features extraction. And for the image process, we can use exceptions, CNN, same XGBoost, random forest. For video, we are taking YOLO model, which extract frames from the open series, and we are using the YOLO models in the version 5, 8, and 9 through the deep learning. So it is a binary classification. First, late fusion, it predict the outputs from the uni models to derive the from final classification. So this system output binary classify it is healthy or it is a diseased person. Through this, identify the confidence score by increasing them. For this, both the combining, we use the Flask based on UI users to upload the data and view the results in the real time. So when we come to workflow or the system architecture, first we have to upload the data, as upload audio, video, and upload the images. When we upload the images, audio, and video, it extract the features and gives the clarification of audio and the images using the audio using the RF and the XGBoost, and the image through the YOLO. And these both features extract after the feature expressions, it classify whether the decision it is a healthy or it is a PD. And here are some data set samples of facial data sets. And the figure 1 shows that PD it's a negative samples, and figure 2 shows that the PD are positive samples. And there are some the dataset samples on audio also, and dataset samples in the image. This is through the uh, this is through the image by writing on the and PD. This is so here also there is a positive samples and the negative samples. There is a lot of difference. And when we come to the conclusion and the future enhancement, in the conclusion, in this project, we build a strong AI system to help the predict Parkinson's disease at an early stage. The system uses multiple types of data server as a voice recordings, images, and video. Instead of relying on just one test, we can go through multiple models. So all these parts are combined in a one web application using Flash, making the system easy to use. We use the advanced AI models like Exception, CNN for image, YOLO for video, XGBoost for voice. This results very good. This voice-based model is achieved 94.9% accuracy, and this video model show almost a perfect detection performance as we are using the YOLO with the version. And when it comes to the future enhancement, we used a advanced multimodal fusion, which means better data combination. In future, the system can combine voice, image, and video data more intelligently using advanced technique using like a transformer based fusion for improving the accuracy. The next longitudinal monitoring means tracking the disease over a time at the correct time. So the system can be upgraded to monitor patients over a long period instead of one just test. You can go through the multiple tests by adding several
Ma'am,
scores based.
your 10 minutes are over, so kindly wrap up.
Okay. Based on the MDS and UPA, doctors can track how Parkinson's disease is processing and the last expanded modalities and explainability means which more data serves and trust in the AI. Future versions can include the variable sensor data such as smartwatches to capture movement and tremor information. Using these explainable tools like Sharp, the systems can clearly show why AI made a decision, increasing the trust and doctors' patients. Thank you.
Okay, what was the limitation of your research work?
Sir, pardon, sir?
What is the limitation of your research work?
Sir, we can limitations means we can it is hard to detect the accuracy, sir, early stage, sir. And so we can use only limited data sets, available data sets, so that can affect the performance, sir.
I'm
And
asking I'm asking with respect to the model that you have created.
sir, according to this, if we have as we have taken the limited data sets and we are getting limited data sets through the disease, so we cannot accurate the correct accuracy for the detection of the symptoms. And it also depends on data quality. For example, for face, it extract for video, it extract every images from the video, even fraction of seconds, expression changes, it calculate everything and give the accuracy. So it is hard to detect accurately, sir.
How do you detect the face from the video?
Sir, pardon?
How do you detect the face from the video?
Sir, when we are taking seconds of video, sir, when we upload to the model, when we upload to the in the technical way, so it extract every frame expressions, everything it will be considered eye expressions, mouth expression, every expressions it is considered and extracting the video into images and it extract the features from the images and it gives the result.
Which library you have used for fetching all these faces from the video?
Sir, I can't hear.
Which library you have used for detecting the face from the video?
We took real-time data also, sir, for this.
Okay, okay. Thank you. Thank you. Okay.
Thank you, sir.
Next presenter, please.
Thank you, sir. Thank you, ma'am. Next,
Thank
we
you, sir.
have Manoj MV. He is presenting Namaratha, the future of smart and sustainable farming. Do we have Manoj?
Yes, sir.
Okay, sir. Show your screen.
Yeah, just a minute. Is my screen visible, sir?
Yes, sir. You can start.
Yeah. Thank you. And our project is Namareta, the future of smart and sustainable farming. And our team members are Banu Prakash, Maitreyi MT, Vivek CN, and myself Manoj presenting today our project under the guidance of Mr. Bharat Bharatwaj, BS, Assistant Professor, MITT, CSC. Today I am going to cover about introduction, literature review, literature survey, proposed approach, and methodology, data sets used. And also I will show you the experimental results and test cases. Coming to the introduction. So agriculture is an center to Indian economy, but faces many challenges such as unpredicted weather, pests outbreaks, and reliance and lack of communication, market access, middleman further reduces the profits, and also we are less use of technologies like AI, ML, IoT, and farming tools. Our system, number eight, the farming. Number eight, proposes an AI-powered digital platform offering crop monitoring, disease prediction, verified input procurement, direct farmer to buyer linkage, contract farming, and also weather based on the location, and weather based diseases can be provided. And literature. What is the gap between the existing system and our system? So our system supports better AI and ML support for crop selection, fertilizer use, and irrigation using soil and weather data. AI-based our system AI-based disease prediction enables early identification and reduce crop diseases. And our system mainly reduces the middleman by introducing digital platform for farmer and buyer connectivity. Existing systems lack this farmer and buyer connectivity and lack full integration of this system. And farmers still face limited access to real-time guidelines and fair markets. As we know, the farmers mainly depend on the vendor suggestions or any other co-farmer suggestions, where they were not getting an expert suggestions for their crops. So we integrate AI-driven platform for combining smart crop guidance, disease prediction, verified input for fertilizers, pesticides, seeds, and tools, and in a digital marketplace for selling their products through our website or an app. So literature survey, and we have done few literature survey where the AgriConnect is an basically e-commerce platform for supply chain of the fertilizers, and it uses government datasets and AI disease identification and yield prediction. This uses plant village and CNN model for real-time disease prediction and crop guiding, uh, where it has lacks some limited data sets and generalization. And a fertilizer recommendation system for leaf. It is similar to the AI disease prediction, where it recommends the fertilizers based on the diseases. And a web-based agriculture recommendation system using deep learning. It uses Kaggle agriculture dataset. Enabling learning CNN and real-time techniques will be used. This recommends the crop and fertilizers via web app and crop growth analysis across Indian states. It uses 4 to 5 states climate and variable data sets for diagnosis and recommendation of crops based on temperature, humidity, and soil. But the lack of but due to climatic variable affects this this project. So coming to the proposed approach, we have developed an AI-driven smart agriculture platform that supports farmers at every stage of farming, where from seeding to the from yield to seeding to the yield. Apply AI-based image analysis for early detection of crop diseases and pests. Give recommendations and remedies to the diseases, and also helps to find the nearby vendor via website. Provides access to verified agriculture inputs such as seeds, fertilizers, and tools, wherein this the farmer can order their fertilizers, seeds, and also tools
from the website where the vendors will be verified through their license and their certifications provided by the Government of India. Integrating a digital marketplace to connect farmers directly with buyers, where the farmer can sell their crops in our website by pricing by adding their adding the yield they have and also the cost of the product. It will reduce the middleman, ensure fair pricing, and improve farmers' profit. Promote sustainable, data-driven, and transparent farming practices for the farmers. This was the dashboard for the farmers, where we can see marketplace community farming, where the farmers will connect and share their knowledge. And contract farming is basically an agreement between the company and the farmer for their goods exchange. And fertilizers, order high quality fertilizers from the vendors, where the vendor will apply in their website, in our website. And pesticides, cropping tools, and also include seeds. And user guidelines, where the farmers can actually get guidelines for the different types of fertilizers to be used and how they are used. And also we have weather notification system, multi-language system, and AI chatbot for disease diagnosis. And we are given multi-language as a Kannada and English as a prayer languages. And you can see the actual our website. If you visit this link, you can get our complete website. Proposed methodology. We have developed an AI centralized AI-enabled agriculture platform for smart farming support. Uses AI chatbot LLM, that is CNN model for prediction. Import crop disease detection using machine learning trained on crop diseases. Follow three-tier architecture: presentation layer, mobile app for farmers, login, AI chatbot, remedies, marketplace, and application layer where the backend server for AI processing and system logic, data layer, real-time database with weather and market API integrations. This was the block diagram where the user will log into the web application and admin manages the user's data. And marketplace, the farmers can upload their farmer market products. Next, AI chatbot integrate with the interact. Farmers can interact with the AI chatbot, and we use basically for AI chatbot plant village dataset that containing labeled images of healthy and diseased crop leaves used to train and test the AI plants. This includes tomato, pepper, potato plants, and also apple and other many fruits and also vegetables. And user generated application data like for profiles, crop inputs provided by the vendors will be also stored, and real-time weather data from external open API weather data we will be providing, and predefined agriculture product data for remedies and marketplace operations. Security.
Sir,
So
your
farmers,
9 minutes are over, so kindly wrap up.
yeah, thank you. We will just see the future enhancement, integration of IoT sensors for real-time soil and crop monitoring, advanced AI model for yield prediction as climate disease, as our present model is giving 78% accuracy. We are aiming for best. And also coming to the pricing of the product based on the quality, we need to price the product uploaded by the farmer. So we are in future we're thinking to integrate AI based product quality certification. So based on the certification, the price will be provided to them. And expansion of contract farming and organic certification features, and enhancing regional language and voice based assistances. These are the few papers we have referred, and thank you. Open to the questions.
Hello, am I audible properly?
Yes, sir.
What are the ethical and data privacy issues in smart farming or smart
Uh,
agriculture?
when we came to ethical,
Yeah,
so
yes.
whoever maybe can be logged into our website. So we need to verify the farmer is the farmer. Like if anybody wants their if they buy as a farmer and sell to others, there will be an ethical issue. And your second question, sir? Ethical and
Ethical and privacy issues in smart agriculture.
Sir, we are using fire-based authentication where farmers can get privacy and they can actually chat to their partners. Like we have WhatsApp integrated.
Okay, okay, okay. Thank you. Wonderful presentation. Next presenter, please.
Thank you, sir.
Thank you, sir. Next, we have Lekhana M. She is presenting prenatal image-based prediction of heart attack and diabetic risk with preventive guidance.
Yes, sir. Am I audible?
Yeah, I'm audible.
Okay. Is my screen visible, sir?
Yes, ma'am. You can start.
Okay. Good morning, one and all. Our project is our retinal image-based prediction of heart attack and diabetic risk with preventive guidance. And I will just briefly explain the introduction part. In the cardiovascular diseases and diabetes are among the leading causes of long-term health complications in the worldwide, often requiring continuous monitoring and accurate risk assessment. And conventional diagnostic approaches typically rely on multiple clinical tests, which can be invasive, time consuming, and expensive. With the recent advancements in medical imaging and deep learning, retinal fundus images have gained attention as they capture rich microvascular information that reflects systemic health conditions, making them a promising source for analyzing cardiovascular and diabetic risk. Coming to the motivation, accurate health risk assessment remains challenging due to the complexity of existing medical evaluation processes. Advances in deep learning and medical imaging create opportunities to analyze hidden patterns in retinal fundus images. This work is motivated by potential to develop an automated and image-based system that supports efficient and reliable disease risk prediction. And the problem statement is in routine health checkups, patients often undergo eye examinations for vision assessment, and risks related to diabetes and cardiovascular conditions remain undetected until advanced symptoms appear. Although retinal fundus images captured during these examinations contain hidden vascular patterns linked to systemic diseases, they are rarely analyzed beyond ophthalmic purposes. As a result, opportunities for early risk identification and preventive guidance are missed. And coming to the objectives of the project, to analyze the fundus images for predicting cardiovascular and diabetic risk, and to extract and learn meaningful retinal vascular features using deep learning techniques, and to generate interpretable risk assessment reports that support healthcare evaluation, and to enable doctor review and analysis of user reports through a dedicated doctor module, and to provide personalized food recommendations and lifestyle guidance based on predicted result. And in the literature survey, we have referred some papers coming to the prediction of cardiovascular risk factors from retinal fundus photographs through deep learning by Poplin at 2022. This study demonstrated that deep CNN models can predict cardiovascular risk factors such as blood pressures, BMI, and hemoglobins directly from retinal fundus images, highlighting the retina as a non-invasive indicator systemic health. And in the second paper, diabetic retinopathy prediction using deep learning by Spurti KV at 2021, the authors applied deep learning CNN-based models to analyze retinal images for diabetic-related retinal changes, showing that retinal features are strongly associated with diabetic conditions. And in the third paper, heart disease prediction using the eye retinal images by Samir Shaikh at 2023, this paper used for transfer learning based CNN models to predict heart disease and related health conditions or retinal images, supporting the feasibility of multi risk assessment using fundus data. And to the proposed system architecture of our project, the user will upload their own fundus images. After that, image pre-processing will be done, and CNN will extract the features through that fundus image. After that, user will get an option like whether to predict cardiovascular or diabetic prediction. After that, risk percentage estimation will be done. Then user will get to display their risk percentage by analyzing their retinal features. Then there will be get an option like food recommendations, lifestyle based on their risk that have predicted. And also, if they want, they can consult a doctor. In the doctor module, if they want, they can mail the doctor their report, and doctor will analyze and send the report back to the user by analyzing their report. Coming to the methodology, in deep learning models, we have used purchased retinal fundus data sets from the bright data containing diabetic and cardiovascular retinal fundus images. And then user will upload their fundus images. Then image pre-processing will be done. Their images are resized, normalized, and enhanced to ensure consistent input quality. And then CNN based model extract retinal vascular and pathological features automatically. And in risk prediction models, there will be diametric module where user will get to know their severity levels in the diabetic retinopathy. And in cardiovascular model, the model will predict their age, sex, cholesterol, and blood pressure, slope, compression pressure, and other clusters, and estimates their heart attack risk percentage. And in doctor module, users can, if they want, they can consult a doctor and review their results. And in preventive guidance, they will be having lifestyle recommendations and food recommendations for them. And coming to the data sets, as shown in the image, the fundus image will be look like this. Data sets will be look like this. So data sets used for the training and testing and validation purposes. And the tools, and coming to the tools and technologies, we have used Python programming language, and in deep learning frameworks, TensorFlow and Keras, and OpenCV for image processing, and CNN for model architecture, and Flask and React for web framework, and Google Colab, Jupyter Notebook, and VS Code for development environment, and CPU, GPU enabled system for hardware support. And in the result and analysis, training and validation accuracy, this graph shows how accuracy changes as the number of training epoch increases. And training accuracy represents how well model learns from training data, and validation accuracy represents how well the model performs on unseen data. And training and validation loss, which shows training loss decreases as the model improves its predictions on training data, and validation loss also decreases, indicating stable performance on unseen data. And in the confusion matrix, it will correct the predictions for disease or non-disease cases for higher than incorrect ones. And lower misclassification indicates effective learning by the model. And in the ROC curve and AUC, different decision thresholds are evaluated to ensure predicted performance. A better curve shape indicates stronger classification capability, and high AUC value confirms consistent and reliable disease prediction. And in the image processing analysis, where the training and evaluation before, retinal fundus images were pre-processed to improve data quality, and all images were resized to 224 into 224 pixels to maintain uniform input dimensions for the CNN model, where the normalizations were applied to reduce image artifacts and stabilize pixel intensity value, and to enhance the model generation and reduce overfitting. And data augmentation techniques such as rotation, flipping, and scaling were used during training. And in the CNN architecture, uh, the proposed system employs CNN due to its effectiveness in automatically feature extraction from medical images, and the architecture consists of input layer followed by multiple convolution layers with the ReLU activation to extract spatial features, and max pooling layers as used to
Ma'am, your
reduce
9 minutes
damage.
are over, so kindly wrap up.
Okay. So I will come to the conclusion and future work. So CNN-based system for predicting diabetic and cardiovascular risk using retinal fundus images, as the proposed system extracts meaningful retinal features through deep learning, risk predictions through separate diabetic and cardiovascular models. And in the future work, we would like to integrate a larger, more diverse retinal datasets to improve generalization and to incorporate the AI techniques to improve clinical interpretability and real-time deployment in clinical and telemedicine environments. Thank you. Thank you.
Thank you. It was a good presentation. What is
Thank you.
your contribution to this research work?
Sorry?
What is your contribution to this research work and how it is going to contribute to the computer science?
Sir, as we know, there are heart attack and many other risks are evolving throughout the world. But AI is something that is ruling over the world. So we thought, why not we apply the AI or deep learning methods in order to these diseases. These things might also help to the society. And
But 100% relying on the AI cannot be the proper solution. It may be a problem for the life as well, right?
sorry, sir.
100% assurance and truthfulness of that AI model that you are using, artificial intelligence, is not correct for decision making also, no?
Yeah,
So
sir.
it is
That's
going to
why
help
we
you.
have used the doctor module, so they can contact the doctor also there itself. They can analyze their report also there itself.
Okay, okay, okay. Thank you.
Thank you, sir.
Okay.
Thank you, ma'am. Next will be the last presentation for the session. Yeah, so the next presentation is presented by R. Hitesh. He's presenting Algorithmic Arcade, a framework for learning data structures while playing game. Hitesh, are you there?
Yes, sir.
Yes.
Can I share my screen?
Yeah, you can. Yeah, it's visible, so you
Is my
can go
screen
ahead.
visible? Yes. Yeah. Uh, Good morning to one and all present. Thank you for giving this opportunity to present at ICTCS 2025. So I'll be presenting our project, which is Algorithmic Arcade, which is a framework for learning data structures and algorithms through a game. Uh, just a second. Yeah. So the challenges for traditional DSL learning. Most existing systems, they teach data structures and algorithms in a very theoretical way, which makes the concepts feel more abstract and difficult to visualize. Learning is often it is passive, where students read or watch solutions instead of actively applying concepts. Feedback is usually delayed, and learners uh, they do not immediately understand their mistakes. So this leads to very low engagement, poor retention, and a steep learning curve. And coming to like the importance of learning DSA, so the data structures and algorithms they form the foundation of efficient software development. They help in solving problems like they help us to solve problems logically. They help us to write optimized code and managing time and memory effectively. So strong DSA knowledge is essential for real world applications as well as technical interviews, and it builds confidence approaching complex problems systematically. So this will be our motivation. Teaching the important concepts of data structures and algorithms in an engaging way for users. So our solution for this will be our platform, which is algorithmic arcade. So it is a web-based a gamified platform which consists of different levels with increasing difficulties. The users will be able to teach. I mean, sorry, the users will be able to learn different fundamentals of data structures through interactive games and each level teaches a different data structure with a varying difficulty. And we mentioned real-time analytics because there is a, these levels, they are all time constrained. solving a level in a shorter time, we can achieve quicker points. And there is a leaderboard to improve the engagement among the users. This will be our system architecture. Front-end interface, which is a responsive web application. It is implemented using the MERN stack. And there is a backend game engine that manages the game state and user interactions. And we, of course, we track the progress of the various users also. So, game-based learning methodology, like we mentioned, the levels they are all according to increasing difficulties. So, for any new user or for any engineering student or anyone who wants to learn data structures, so they can start learning them starting from arrays and lists maybe, and then explore stacks, queues, and even more. We have different levels for stacks, queues, linked lists, trees, AVL trees, red black trees, etc. So the learning flow and the front end is all user friendly and engaging. The player selects a challenge matching their current skill level and learning objectives. Like as he progresses, he keeps scoring and learning the various concepts. And yes, like we mentioned at the beginning, one of the important challenge was immediate feedback. So right after completing the level, he can like during the learning process, he can opt for hints and explanations also, and he gets immediate feedback. So these are the key features of our platform: progressive difficulty levels, real-time visualizations, and analytics to track the user progress, and even an achievement system, a real-time leaderboard system. So impact and future directions. The major uh, the major future direction would be the major benefit would be the educational wise. So nowadays everyone knows the importance of edtech platforms. So game mechanics, they increase the motivation and time on task compared to traditional methods. So there are multiple studies which suggest this. And this also improves the retention. That is how well the users are able to retain the concepts that they have learned and how well they are able to apply the concepts again. And this also reduces the cognitive load. So because will be using visual representations and immediate feedback, this could be better, much better than the traditional systems. And some of the future enhancements would be AI-driven difficulty adaptation. So this we are still working on it. Uh, so multiplayer competitive modes and maybe expanding the algorithm library, that is somehow come up with levels where we are able to teach computer science aspirants about the concepts of greedy and dynamic programming, etc. That's all. Thank you, sir. I'm open for questions.
Okay. How the real, you can say, the manual data structure learning may differ from your work that you are proposing right now in this research?
Like I mentioned, sir. So right now the traditional systems would be learning from YouTube tutorials or through classes at engineering colleges. But when a student approaches this concept via a game, so like where he is tasked with doing something, where he is tasked with achieving something uh, through an interactive visualization, we feel that the engagement is much better because we have already tested it out by sharing the platform with our fellow classmates, and when we have collected the feedback, yes, majority of them agree that it is much more engaging than the traditional methods.
And how you have evaluated those participants in your learning process?
Uh, the evaluation of participants would be based on the like different levels were allocated different reward points, and there's a timer for every level. So the quicker we solve a level, so the quicker the game completes, the more reward points the participant might get.
And how do you incorporate the feedbacks of the participants in your work?
Feedbacks, like while we are testing it out, it was through a Google form, but right on the platform we do not have a thing for collecting the feedback. Yes, maybe we can incorporate it so that we can improve on the platform.
Okay, okay. Thank you. It was a nice presentation. Wonderful.
Uh, Thank you, sir.
Thank you, sir.
Thank you.
So I sincerely thank our authors and their excellent presentation and contribution in this session, and all our participants for being part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during the 10th version and all previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026. All the participants would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months, so kindly cooperate with the team ICTCS 2025. A small token of appreciation to the chair, Dr. Krishna Kanta, for chairing this session. Just a second. Sir, do you have any closing remarks for the participants?
Yeah, I would like to extend my heartfelt gratitude to all the organizing committee for inviting me in this 10th International Conference ITCS 25. I would also like to extend my sincere appreciation to all the presenters, participants, and organizers for their dedicated research work that they have showcased in this presentation. We look forward to see you again in the future conference and contributing this journey of knowledge, innovation, and collective growth together. Wish you all great success ahead. Thank you very much, all the participants and the organizing committee.
Thank you, sir.
Thank you, sir.
Thank you for your presence. I request everyone to switch on their cameras for a quick snapshot of the meeting. Thank you. Have a nice day, everyone.